You know, we all pretty much take it for granted that the universe is, well, permanent, a solid, unchanging stage where everything happens. But what if it isn't? What if the very fabric of reality is living on borrowed time? Today, we're going to open a cosmic cold case file and investigate one heck of a question. Is our universe built to last?
So yeah, that's the big one. That's the question at the heart of it all. We're about to challenge that core assumption that reality is forever. We're going to explore a scenario where everything you know, every single star, every planet, every atom could be wiped clean in an instant.
Okay, to get our heads around this, there's one key idea you've got to know: the false vacuum. Just imagine our universe is relaxing in a nice, comfy valley. It feels stable, right? Everything's good. But what if, just over the ridge, there's another valley that's way, way deeper and even more stable? That's the situation we might be in. A false vacuum. It's stable for now, but there's always that chance it could tumble down to a lower, more fundamental energy state.
All right, so we have our key concept, the false vacuum. With that in mind, let's officially kick off this investigation. The first piece of evidence we've got to look at is a simple but pretty profound idea. Our universe's stability is just not a guarantee.
First things first, we need to totally rethink what we mean by empty space, because in quantum physics, the vacuum is not a void. It's not nothing. It's this buzzing, roiling sea of energy, the ground state for all the fundamental fields that write the laws of physics. And this energetic stage, well, that's the scene of our potential cosmic crime.
So, with the scene set, let's meet our prime suspect. It turns out the fate of our entire universe seems to rest on the shoulders of one field in particular, the Higgs field.
See, the Higgs field is what gives other fundamental particles their mass, but its own stability is caught in this incredible cosmic tug-of-war. And the specific properties of certain particles, those are the critical clues we need to look at right now.
Okay, now check out this investigator's case file. This is where it gets really interesting. On one side, you've got the Higgs boson. Its mass, about 125 giga-electron volts, basically carves out the shape of the valley we're currently in. But on the other side, you've got this absolute heavyweight, the top quark. It's so heavy it provides this powerful, destabilizing force, constantly trying to push the Higgs field over the edge and down into that deeper valley.
So what's the crucial takeaway here? Well, when physicists plug these exact numbers into their equations, the evidence all points to one shocking conclusion. Our universe is metastable. It's not perfectly stable, but it's not immediately unstable either. It's in this in-between state. It's living on borrowed time. Although, as we're about to find out, that loan is for a very, very long time.
So, what would actually happen if our universe's cosmic luck finally runs out? Let's take a look at the mechanics of this, the ultimate catastrophe.
It all kicks off with a process called bubble nucleation. Somewhere way out in the middle of nowhere, a random quantum fluke could happen, allowing a tiny patch of space to tunnel through that energy barrier into the true vacuum. A little bubble of a new universe appears. Now, if that bubble is just big enough to overcome its own surface tension, then it's game over. It becomes unstoppable, expanding outwards in all directions at nearly the speed of light.
And this isn't just some threat to life on Earth. It's a threat to physics itself. The physicist Sidney Coleman, who did a lot of the early work on this, he just nailed it. He called it the ultimate ecological catastrophe. It's not just an extinction event for us. It's an extinction event for the very laws of nature as we know them.
Think about it. Inside this expanding bubble, reality is completely different. The fundamental rules are rewritten. The Higgs field has a new value, which means the masses of things like electrons and quarks would totally change. Atoms and molecules, they just fall apart instantly. Chemistry, the basis of you and me and everything, would just stop. Some theories even suggest the new physics would cause space itself to collapse into a big crunch.
And here's the real kicker. The wall of this bubble expands at, or incredibly close to, the speed of light. That means there would be absolutely no warning. No telescope could see it coming because no signal can travel faster than the wall itself. One moment, the universe is here. The next, you and everything you've ever known have been converted into the new vacuum.
Okay, that's a lot. That's the terrifying part, but hey, every good investigation has to consider all the possibilities, and modern physics might just provide our universe with a perfect alibi. So, let's explore some of the things that could save us from this cosmic doom. Our first potential hero is actually gravity. Yeah, good old gravity.
When you start including Einstein's general relativity into the calculations, the picture changes. What this table is basically showing us is that a transition from our kind of flat spacetime to a different, more curved kind of space actually makes it harder for one of these bubbles to form. Gravity can actually suppress or quench the decay, making it way less likely.
So what could even trigger this? Well, a spontaneous decay, just a random fluctuation out in empty space, is incredibly rare. A more likely culprit might be what's called seeded decay, where something like a tiny evaporating black hole could provide the energy to get the process started. But even then, the simple fact that we're still here, 13.8 billion years later, puts some really tight limits on how likely that can be. Now, a question that always comes up is, could we accidentally trigger this with our particle colliders? And the answer to that is a hard no. And we know this because the universe has been running this very experiment for us for billions of years. Cosmic rays, particles with way more energy than anything we can create at the LHC, have been smashing into planets and stars since the dawn of time, and nothing has happened. That's some pretty solid evidence we're safe on that front. And finally, there's the biggest alibi of all. Our current understanding of physics is probably incomplete. There are a bunch of really promising theories for what lies beyond what we know, the usual suspects, if you will. Things like supersymmetry, or new undiscovered particles or fields. Any one of these could fundamentally change that cosmic balance, providing the missing piece that makes our universe 100% permanently stable.
So, after reviewing all the evidence, the suspect, the catastrophe, the potential alibis, what is the final verdict on the fate of our universe?
The verdict is in. Don't panic. Seriously. While our vacuum might be metastable, the calculated lifetime is just staggering. The best estimates put the time before spontaneous decay could happen at more than 10 to the 100th power years. That number is so ridiculously huge that the universe will have long since died of heat death before this is ever a concern.
But here is where the story takes this absolutely fascinating twist. In some models of cosmology, vacuum decay isn't an act of destruction at all. It's an act of creation. The theory of eternal inflation suggests that our entire universe is just one bubble in this vast, eternally expanding multiverse. In that picture, our own Big Bang was a vacuum decay event, and new universes are being born this way all the time.
Oh, and having a finite lifespan also solves this really weird cosmic paradox. In a truly eternal universe, random fluctuations could eventually just pop a fully formed, conscious brain into existence out of the void. They're called Boltzmann brains. Bizarre, I know, but a limited lifespan for our vacuum neatly prevents that from happening, which is kind of nice.
And you know, this isn't just some crazy theory anymore. In 2024, an incredible experiment in Italy brought this cosmic drama right down to Earth. Scientists actually created a kind of false vacuum in a supercooled gas and literally watched as bubbles of a true vacuum formed and expanded. They proved the fundamental physics behind this whole cosmic process is real. Which leaves us with a final, pretty profound question. After weighing all the evidence, we know we're safe, but the way we think about our reality might be forever changed. And we're left to wonder, is the cosmos we call home some kind of eternal monument, built to last forever? Or is it something maybe even more special, a magnificent but temporary phase in an endlessly creative and evolving multiverse?